Exam for review, which covers Chapter 6 and Sections 7.6 and 8.1. The instructions are important to make sure that you know when to factor and when to solve. Remember, you cannot solve if there is not an equal sign. So number 1, t squared minus 16. With this, to factor this expression, it is a difference of two terms. It's two terms. So we'll look at two terms. We think of difference of two terms. There's no greatest common factor to take out. T squared is a perfect square and 16 is a perfect square. So creating our answer area, t squared is t squared, so we put a t in the first part, plus, minus, and then 4 squared is 16, so we put 4's in the second spot. Number 2, x squared minus x minus 12. Number 1, it is already in descending order. Number 2, there is no greatest common factor to take out. So since the lead coefficient is a 1, meaning first term is just an x squared, I'm going to create my answer area, and I'm going to look for the factor pairs of negative 12 that add to a negative 1. And I see them right away. You can look through the different factor pairs if you want, but we'll see that when I look at 3 times negative 4, I get negative 12, and 3 plus negative 4 is a negative 1, which is what I needed because it's the b term. So I get x minus 4, x plus 3. Number 3. T squared plus 81. This would be the sum of two perfect squares. And the sum of two perfect squares is always prime. We cannot factor the sum of two perfect squares, so we write prime. We can factor the difference, right, when we subtract two perfect squares, but we cannot factor the sum of two perfect squares. Number 4, x squared plus 7x plus 33. Let's go ahead and create our answer area, and then we're going to look for the factor pairs of 33 that add up to positive 7. Well, the factor pair for 33, we have 1 and 33. We have 3 and 11. And that is the extent of the factor pairs that multiply to 33. The first pair adds up to 34, so it does not work. And the second pair adds up to 14, does not work. So we cannot factor this trinomial any further, and we would say is prime. It is prime. Number 5, we have 4 terms. When we see 4 terms, we factor by grouping. So we look at the first 2 terms and we take out the greatest common factor, which is an a. What is left from the first term is an x, and what remains from the second term is a y. Bring down the next operation, which is a plus sign. Now we're going to look at the second set of terms, 4x plus 4y, and we can take out a 4. What remains from that first term of 4x is x. What remains from the second term of 4y is a y. Now we see that we have this common term in each, or common factor in each of the terms, the x plus y. So we take that out front. We factor out the x plus y. We open another set of parentheses and write what remains, the a from the first term plus 4 from the second term. So the binomial x plus y times the quantity a plus 4 is our solution. Number 6, x squared plus 4x is equal to 21. One thing this should say is to solve. All right, this one should say solve because it has an equal sign. So the first thing I do to solve this quadratic equation is I'm going to get it equal set to 0. So I'm going to subtract 21 from both sides. And I get x squared plus 4x minus 21 is equal to 0. Now I will look at how to factor x squared plus 4x minus 21. Now the first coefficient is a 1, that x squared. So we'll look at the factor pair for 21 that adds up to 4. 7 times negative 3, see it right away because I've done a lot of practice, and it adds up to a 4. So I know that this will be x plus 7, x minus 3. Now I need to find the solutions. So I set each of these binomials equal to 0. So I have x plus 7 is equal to 0, or x minus 3 is equal to 0. Solving each of these smaller equations, x plus 7 equals 0 when x is equal to a negative 7, or x minus 3 equals 0 when x is equal to a positive 3. Now this is a fine way to represent your answer, or group them some way so that we can clearly indicate or find what you meant for your answer to be. So I would like your answer expressed in one area on your test. So x is equal to negative 7, or x is equal to 3. Number 7. 3x squared, sorry, let me start again. 3x cubed minus 18x squared minus 21x is equal to 0. So what we will start to do this quadratic-like equation is it's set equal to 0, and the quadratic side is in descending order. I see that there is a common factor, a greatest common factor of 3x, and then what remains when I factor out that greatest common factor is x squared minus 6x minus 7. It's still equal to 0. And what I need to do now is I'm going to focus on the inside. I have to factor completely, which means I factor everything until it cannot be factored. So focusing on the inside, I bring along the 3x, and I look for the factors of negative 7 that add up to a negative 6. And when I look at this, I have negative 7 and 1 gives me a negative 6. So I will have x minus 7, x plus 1. Setting each of these factors equal to 0. So I have these smaller equations. I end up with the first, if 3 times x is equal to 0, in the first smaller equation, we get x is equal to 0. If x minus 7 equals 0, then x is equal to 7. And if x plus 1 equals 0, or x is equal to a negative 1. And this is how we can express our answer. Number 8. T squared minus 25 is equal to 0. The equation is equal to 0, and it's a difference of 2 squares. So I can put in here t plus 5, t minus 5, set each of these binomials equal to 0, solve each equation. If t plus 5 is equal to 0, we can say t is equal to a negative 5, or if t minus 5 is equal to 0, then t is equal to 5. This is a fine way to express your answer, but you could also write it like this, that t is equal to plus or minus 5. Moving on to material from section 7.6. Solve the proportion. When we're going to solve this proportion, we can cross multiply. So, but if you look, we can actually solve this. We'll do it two different ways for this review. We can cross multiply by doing the means. Product of the means is equal to the product of the extremes. And that would give me 7 times 52 is equal to 13 times x. And then divide both sides by 13. And I'm going to do that before I do the multiplication, because I see that 13 goes into 52 4 times. I'm always looking for a way to simplify my answers by canceling. So here the answer is x is equal to 28. Another way that we could do this would be to look and see that if I multiply both sides of the equation by 52, I see that that clears the denominator from the x. And again, 13 goes into 52 4 times, and I get x is equal to 28. So either way, you get the same answer. It really depends on what you see as your first step. Number 10, solve the proportion. Well, for this proportion, I will do my multiplication of the means times the extremes. So that looks like x minus 4 times x plus 3 is equal to x times x plus 5. So our next step would be to multiply. Now, for the binomial, you would FOIL, and after you combine terms from FOILing, you get x squared minus x minus 12, and on the right side you distribute and you get x squared plus 5x. I'm going to subtract x squared from both sides to simplify, and then I'll add x to both sides to get my x term on one side and my constant alone on the other. Dividing both sides by a 6, I get x is equal to negative 2. Number 11. Given the similar triangles, triangle ABC and triangle PQR, find A and B. What we know is that corresponding sides of similar triangles are proportional. Now they give us the sides that 8, this relationship between the similar sides 8 and 6.4. And with this first, we're going to find A first. We see that we have 7 and corresponds to A. So in writing the proportion here, I'm first going to find A. I would write 6.4 is to 8 as A is to 7. That is supposed to be an A. Let me write that a little bit nicer. Here's my A. All right, to solve this, I'm going to multiply both sides by 7. They cancel. I see that A is equal to, okay, well, A goes into 6.4. That would be 0.8. Okay, I'd have to keep my decimal. And then we end up with A being 5.6. The multiplication that you do, take your time to simplify the fraction, but we get A is equal to 5.6. Now let's find well, I look for that and see that B corresponds to 6. So I will write 8 is to 6.4. Remember, I can start with my proportions with the whatever goes in the numerator and denominator any way that I want. I just have to be consistent. So 8 is to 6.4 as 6 is to B. And you can see that with the way this proportion is set up, that I'm going to have to do the means are equal to the extremes. So 8b, the means, are equal to 6 times 6.4. I'm going to divide both sides by an 8. B is equal to 8 goes into 6.4, 0.8 times 4.8. So there would be my answer. A is equal to 5.6 and B is equal to 4.8. Number 12. Due to space problems at a local university, a 20-foot by 12-foot conference room is converted into a classroom. Find the maximum number of students the room can accommodate if there are to be 9 square feet of floor space for every student in the class. Okay, so what we want to know is the number of students. So X is going to be equal to the number of students. We can put in a 20-foot by 12-foot conference room. Now, the comparison that they give us is in square feet. So they found that 9 square feet of floor space for every student. The dimensions that are given to us for the entire room, in fact, it's going to be the number of students in the room is what we're looking for. We get the dimensions. So we need to know the square footage of the room. So since it is a 20 by 12, looking for area of the room, we get 240 square feet. All right. So what we can say is that X, or we'll go that 240 is so that's the square feet of the room, is to 9 square feet, or feet squared, as X students are to 1 student. Because we know that we're trying to find how many students in a 240 square foot room. If there is to be, for every 1 student, there are to be 9 square feet of space. All right, so let's do a little simplification because we already have X alone on one side. All right, so let's see, some canceling. I see that 3 goes into 9 3 times and 3 goes into 240 80 times. And so if I divide 80 by 3, I get 26 and 2/3. So 80 divided by 23, or I'm sorry, 80 divided by 3 is 26 and 2/3. If you need to, do the long division on your own. Now, when we're talking about students, we're not going to talk about 2/3 of a student. That just sounds weird, right? So we're going to say that 26, our answer is 26 students. And you can make the answer longer. 26 students are allowed in the room if you want. Number 13, this is material from 8.1, which it is combining the function notation information that we had studied before with the linear equation that we had studied before. Now graph the linear function on the coordinate plane provided. And with this, we have f of x is equal to -3/2, or -3x plus 2. Now you can do this a few different ways. We can draw a table where we have, this is our x, our y, remember y is equal to f of x. Okay, so 3x plus 2 and then we'd have our ordered pair x, y, and we'll just find 3 points. So if x was equal to a 1, f of 1, putting 1 into the function, would be 3x minus or plus 2, which is a minus 1. So we get the point 1, negative 1. When x is 0, f of 0 is 2, and we get the ordered pair 0, 2. And let's do negative 1. When x is a negative 1, f of negative 1 will be, it ends up being 3 plus 2 or 5, and we get the ordered pair negative 1, 5. Now, plotting these 3 points, we get 1, negative 1 is right there, real small. 0, 2, right there. And, oh, let me start over there. I did that one wrong. So 1, negative 1 right here. There we go. And 0, 2, and negative 1, 5. I'm going to grab my ruler, and I will draw in my line. Now you can also just check this. If you look at the basic form, that is in slope-intercept form. So your slope is a negative 3, and your y-intercept would be a positive 2. B, find an equation of the line graphed, and then write the equation using, sorry, that's spelled incorrectly, function notation. Let's cross out the G. So when I look at this, I see that I have a y-intercept of 1, 2, 3, 4. So B would be equal to 4. When I count out the slope, right, it's going to be rise over run. So I go up 1, 2, 3, 4, and then I would shift over 1, 2, 3. So just counting out the slope, I will see that my equation would be 4/3 x plus 4, but it specifically says function notation. So I will write this as f of x is equal to 4/3 x plus 4, and the y equals f of x as well. So we just replace the y with f of x. And 14, find an equation of the line with slope of 2/5 and y-intercept of 0, 3. Write the equation using function notation. So my slope is equal to 2/5. Now my y-intercept is 0, 3. So b is equal to 3. So to write this in function notation, I would write this in slope-intercept form. So here's my slope, and here is my intercept. So f of x is equal to 2/5 x plus 3.